Okay, so good afternoon, everybody. So guys, in this section, I explain how can you do branch instructions. So how can you do if statement, if else statement, how can you do switch case, all this statement, okay? How can we create all these statements using compare and branch instruction together? That's what I did here. So the idea is that we need to use a combination of compare and one of the branch instruction together to create some kind of a branch. And then once you create a branch, you can make any statement, any statement similar to the statements we use in any programming language. For example, like if statement. So here I explained in this example, how can we do if statement? How can you do if else statement, okay, in assembly using combination of compare and branch instructions, okay? Also, I explained how can you do if else if, something like that, switch case, all these statements. And then after that, I move to loops. Loops here, as I told you, it can be for loop or it can be while loops. So also I explained here for while loops. For example, here, no, not this one. For while loops, I explain how can you do while loops using assembly. Yeah, something like that. For example, I want to do something like that, guys. While a does not equal 0, so I have a condition here. So I want to keep looping. I want to keep looping as long as this condition is true, right? So the way I did it, as you see here, guys, in every iteration, as you see here, I'm going to compare e to 0. Once it is equal, equal is the opposite of this condition. Okay, that means this condition is false. So here I'm going to check if this condition is false. Once I find that this condition is false, please go out. I'm done. Go outside, as you see here. So in every iteration, I'm going to compare e to 0. Once I find it is equal to 0, that means this condition is false. I'm going to go out. If e does not equal 0, I'm going to come here and then I'm going to use unconditional branch to come back to here. So to make it very simple, guys, as you see here, all the time, once I come here, this one, there is no condition. Bring me back to here. Once I come here, go back to here. Come here, go back to here. The only way to get out of this loop is by this one. When this condition is true, okay? When a is equal to 0, this one is going to bring b out here. Is that okay? Makes sense? Also, look here, guys. I give you one example, but you can use it for any other case. Let me give you one example first, okay? Here, I'm telling you if the condition is not equal. What if the condition, for example, was greater? Okay, guys? Okay, you can do the same thing. Here, I'm going to check for if the condition is false. The condition is false to go outside. So I'm going to do the same thing. Condition is false means it is less than or equal. So here I'm going to say branch if less or equal. That's it. You got what I'm saying? So here I give you one case, but you can still use the same logic for any other case. Okay? That's why I'm not teaching this specific case. I'm teaching the idea or the technique. The technique is here. I'm gonna check if the condition is false. If it is false, go outside. This is the technique. So whatever the condition you have here, I'm gonna check if it is false. Okay. So in case of not equal, this condition is gonna be false if it is equal. In case of greater, this condition is going to be false if it is less or equal, and so on. Okay. Yes. What's your question? Yes. No, this is a very good point. Okay. First of all, let's agree on this one. Okay. Any label, guys, just names. They are not commands. You can use any name. Let's agree on this first. Is that okay? So any label I use, okay, is actually a name, any name. However, as you know from other programming languages, when you select a label, you should not select a command and use it as a label. You got what I'm saying? That is why I'm very careful. I don't want to use end, because end is gonna overlap or it's gonna interfere with another command. You got what I'm saying? So that's why I put underscore, just in case end was a keyword already. Okay, that's it. That's the only reason. Okay. No, because I'm not expecting there is a condition. There is a condition called to begin. I'm not expecting that. Okay. But here maybe end is a command. That's why I put here underscore. Maybe if is gonna confuse code warrior. That's why I just put underscore here. You got what I'm saying? But it's just any name. Let's agree on this. Any name. Okay. Any question, guys? Okay. Yes.
Is the compare to 0 redundant in this case? Because doesn't the long branch equal check?
Sorry, say it again. Say the last part again.
The long branch equal checks the 0 flag. So isn't it redundant?
Okay, look here. This one, yes, this one is gonna check the 0 flag. Yes, you are right. But before I check the 0 flag, I have to set the 0 flag first. You got what I'm saying? So in this case, if I remove this one, here the 0 flag is gonna have the last value based on what instruction you did here. You did addition, subtraction, whatever. You got what I'm saying? That's why this one is not a redundant in this case. It's not. Okay, because this one is gonna check the 0 flag. So I have to make sure I have to set the 0 flag based on the comparison to 0. So here it's not a redundant. I know what you are referring to. The other one was a different case. In the other one, here you load. Let me remember. I think you load register A with a counter. So you load A with a counter and then compare A to 0. Is that okay? And this one is going to check the 0 flag. In this case, if this is the case, actually compare here is redundant. You don't need it. Why? Because this load is going to set the 0 flag if counter is equal to 0. Anyway, again, you should do your best to understand it. But again, in my opinion, it's much better if you are going to write some redundant instruction and the program is working, much better than just it's not working in general. You got what I'm saying? But anyway, but you should also, to better understand this course, you should understand here also in this case, I may not need to compare because load is gonna update the 0 flag if counter is 0. Is that okay? Anyway, and this one is gonna only look at the 0 flag because every branch is gonna look at different flags, and already you have in the table what flags in the table in chapter. I show you what flags every branch is gonna use. Okay. So this is example for while loop. Also, we did while loop in the last lab. Okay, so also I explained here how can you do while loop for last lab as well. Yeah. So here in the last lab, you have array. Okay. So in every we have here a pointer. This pointer here in iteration number 0. Then this pointer is here in iteration number 1. This pointer is here in iteration number 2, and so on. In every iteration, I have to look for a delimiter, which is a special number. Once I find this special number, so I'm going to leave. That means this is the end of the array, and I have to leave, right? That is why in every iteration I have to check. So once X is here, once I read the element, I have to check: are you delimiter? Yes, leave. No, make iteration, and then move X to the next one and to try again until you find the delimiter. Is that okay? That's exactly what I did. So as you see here, guys, as we did in the last lab, X is pointing at the very first location in the array. This is how you initialize the pointer. You initialize the pointer at the first element in the array, and then here. This is the beginning of the loop. Loop should begin here. Here I'm gonna read the byte. I'm gonna read the byte pointed by X. So X is here, so I'm gonna read this byte. I'm gonna put it in register A. Then I'm gonna compare it to the delimiter. Are you equal to the delimiter? Is that okay? Yeah. So yes, if it is equal, here I have to use compare here. I have to use compare. Is that okay? because I'm gonna compare to -128. If I want to compare to 0, so I don't need it because this one is gonna clear if it is 0. Anyway, so here I have to use compare. Anyway, so if it is equal, that means it's already the delimiter, so I have to leave. I have to go outside. Otherwise, I have to come here. I have to increment X, and then I have to branch to begin again to try again. So this is while loop. So I'm gonna loop until while the element does not equal delimiter, keep looping. Is that okay? Also, for now, I wanna for loops. How can we make for loops in assembly? I told you the idea is very similar to how we did it in C language. So let's first explain how we did for loop in C language. All what you did, as you see here, guys, for I is equal to 0. So I have to use a counter here. So I have to use a counter here. Okay, I have to initialize it with 0, right? Every iteration I have to increment it by 1, right? And then I have to check with the n. Is that 10? No, keep looping, right? That's how we did it in C language. Because I'm saying, so I should have like a counter. This counter, I'm gonna start it with a certain value, initial value. Every time I have to increment it, or you can decrement, whatever you want to do it. And then every time I have to check this condition. Okay. So I'm gonna use the same thing, similar idea in assembly. However, here, your counter here, it can be a memory location or it can be a register. Right? I can use a register or memory location. My advice to you, if you have the choice, it's much better to use memory location. Why? As I told you before, because we have too many memory locations, but for registers, we have just limited number of registers. If you use one of them as a counter, maybe inside the loop here, you want to use the same register. It has a solution. I'm going to explain it. But anyway, in general, we have too many memory locations. Is that okay? Anyway, so I'm going to explain the two approaches anyway. So I told you, if you want to do for loop in assembly, we have two different ways, guys. Okay. I told you, you can use compare and branch instruction, okay, to do that. Or you can use already, we have some loop instruction. Okay, I didn't explain them yet. Okay. So now I'm going to explain how can we do for loop in assembly by two different ways. One way, you can do it using compare and branch instruction. I already explained this one. Okay. And also the second one, I didn't explain yet using loop instruction. Okay. And also I told you what is the advantages and disadvantages of each one of them. Okay. So I told you here, this one is very easy, as you will see today. Why this one is very easy? Because as you will see, it's just one instruction, a decrement or increment. So it's just one instruction. This instruction actually is going to do 3 operations in one instruction. That's why it's easy. So it's going to decrement, it's going to compare, it's going to branch. 3 instructions in one instruction. That's why it's 3 operations in one instruction. Was that okay? That's why this one is just easy to use. Okay, that's a good thing. What about the bad thing? The bad thing is here, your counter has to be a register, right? And I told you sometimes it's not a good idea because we don't have too many registers and so on. Okay. There is also one bad thing. The other bad thing is this one is short. The jump is short. We don't have long version, so you cannot jump for a very long distance. Okay. Here, your counter can be register, or it can be memory location. You can do that, and you can make it long. You can make it short. Okay, right here. Anyway, so I'm going to explain both of them. So I already explained this one, so I'm going to go through it quickly. For this one, I give you here, I explained this example last time. So I told you I'm going to use a memory location, whatever you call it. I'm going to call it counter, whatever you call it. So, okay. And then I'm going to initialize it with number 10, as you see here, guys. and then every time I'm gonna load. When you load and you can compare to 0. So when you load, you compare to 0, or if you are confused, you just add it. This is the one that's redundant, but anyway. So I'm gonna, if in every iteration, I'm gonna load counter, I'm gonna compare it to 0. Once it is equal to 0, just to go outside. In every iteration, I'm gonna decrement the counter, decrement it, and then go back again. Okay, so what's gonna happen? I'm gonna start here from 10, right? This is the beginning. Second iteration should be 9, and so on. Okay, until once it is 0, we're gonna leave. Once it is equal to 0, just leave. Okay, guys. Any questions? Okay. This is how can you make full loop. For example, for 10, you can do it in another way. Here, similar to full loop. So if I go back to full loop, guys, sometimes you increment, sometimes you decrement. So here I explained to both of them just to understand more. So it's not about one of them is better than the other. No, I'm just explaining different ways just to understand the topic more. So for example, here I created it in a different way. I started here from 1, right? Every time here I'm going to compare to 10. Once it's equal to 10, just leave. Every time I'm going to increment the counter and then come back to check again. So here I'm going to start. Counter is 0, counter is 1, all the way until it is 10. Once it's 10, I'm going to leave. Okay, guys. By the way, are you gonna sorry, I'm gonna start from 1. I'm sorry, as you see here, I started from 1, right? So I started from 1, and once it is 10, we're gonna leave. Okay. Sometimes here, based on this structure, or based on the way I did here, I started from 1, I'm gonna compare to 10. Sometimes even myself, okay, sometimes I get confused. If I do this way, this one is gonna 10, is gonna make 10 iteration, or 9, or 11. So sometimes I get confused. Anyway, the simple way to remove any confusion, just, okay, assume it is a small number and check. For example, I start from 1. Look here, guys. I'm going to make this one a small number, like 2, for example. Let's see, if I put 2, I'm going to make 2 iteration, or 3, or 1 iteration. Let's see. A small number, so it's easy, you can calculate it. So here, I'm going to come here, in the first iteration, counter is 1, right, in the first iteration. Is that okay? Then, because if it is not equal to 2, I'm going to leave. Once I come here, this one is going to make counter is 2. Now we start with 1, now it is 2, right? Once I come back here, so then I'm going to leave. So if you put here 2, you are going to make only 1 iteration. You get what I'm saying? So that means if I put here 100, so I'm going to make 99 iterations. Very simple, very simple. You get what I'm saying? So if you want to make 100 iteration, you have to put here 101. Is that okay? Because I started from 1. Or if you start from 0, the story would be different. If you start from 0 and you put here 2, so I'm going to make 2. Anyway, so try small number and you can figure it out. Okay, any question, guys? This is how can you make full loop. One also very important thing I explained last time, very, very important. Look here, guys. If you have an array, in case of an array, this array has 100 elements in the array. Usually, what we do in any programming language, and that's what you learn in C language. If you have an array and you want to scan or you want to read the elements of the array, as they told you in C language or any other programming language, you have to make for loop. Okay, if the array is 100 elements, you have to loop 100 times. Is that right? In every iteration, you are going to work on one element. Okay, so for example, here in this case, so I told you you can, for example, you can make for loop like this one, and you can put here, for example, 101. I told you 101, you are going to make 100 iterations. 100 iteration. Okay. However, here you need a counter to create the loop. Also, you need a pointer. You need also a pointer for X. So you need two things now. I need a counter to make a loop. Also, I'm going to use register X as a pointer. Yes, you can do that. If you are okay with that, yeah, it works. It's okay. It's okay. However, I have a smarter idea. What is the smarter idea? And instead of using two things, one to count and the other one as a pointer, I can use only pointer. Okay. So that's my advice to you. If you want to work on arrays, try to use the other approach. Just it's going to make programming easier. That's it. So I give you here several examples before. So for example, here, I told you the way you are going to do it. This is the for loop. So I want to hide everything here except this is the for loop here. Okay. So here, I'm going to start from location 2001. And then every time I'm here, as you see here, guys, I'm going to compare to array plus 20. So I'm going to compare to the last element here, which is array plus 20. We have 20 elements in the array. You get what I'm saying? So if we have 20 elements in the array, so you have, this is the beginning address. Then you have to add how many elements here. So in other words, let's make it simple. In other words, how you told us you have a smarter idea in which you are going to use the pointer also as a counter. Okay, how? Very simple. The idea is that, look here, guys, because I need a pointer anyway. So a pointer is gonna, X is gonna be here in one iteration, then X is here, then X is here, then X is here, then X is here. Once I finish the last element, X will be here. That's what I'm doing. That's what I'm gonna do. Once X come to here, so I'm done. So how can you get this address? This is the question. You got what I'm saying? So X in the beginning is here. So once I finish, and X come to the end here, and I finish this element, right? So I finish this element, so now I'm done. So how can you get this address? I told you the way you have to get it. I'm gonna compare X to the beginning address plus number of elements. Okay, that's what I explained. Anyway, so now guys, I'm gonna move. I want to move to this one here. I want to move to this part here. I'm gonna explain here how can you use this instruction. We have a number of instructions here. We call them loop instruction. I'm gonna teach how can you use this instruction to make for loops. Okay, but also keep in mind it's gonna be easy as you will see right now. But keep in mind this instruction are only used for registers as counter. You cannot use memory location as a counter. Also, this short, it cannot be long. Okay, so let me explain how it works. For example, here, guys, let's see here. So, for example, we have D, B, N, E. So, what this means? I'm going to tell you what it means. D means decrement. So, this instruction is going to decrement, and it's going to branch if not equal 0. Look at D means decrement, and B means branch if not equal to 0. This instruction. This instruction decrement and branch if equal to 0. This one, I means increment and branch if not equal to 0. Increment and branch if equal to 0. So for now, some of them increment, some of them decrement, some of them is going to branch if equal to 0, or it's going to branch if not equal to 0. Yes. Okay. And again, use whatever help you to create a full loop, as I'm going to explain right now. Okay. The last two, they are not going to increment or decrement. The last two is going to be test and branch if equal to 0. Test and branch if not equal to 0. You remember, I explained the one instruction before, we call it test. You remember, this test is going to compare to 0. So when I test, I compare to 0. So this one is going to compare the counter to 0. If it is equal, it's going to loop. If not equal, it's not going to loop. Yes. Short instructions, okay, are more efficient than long instruction. Efficient regarding how much space they need in memory and also regarding execution time. Okay. So, however, you have to be careful here because in case of short, you have limited space. You can jump only through a certain number of instructions. So if you have a few instructions, it would be okay. But if you have many instructions, it's not going to work. You're going to get error. Okay. And then you have to use long. Look what I'm saying. Here we don't have a choice. All of them are only short. Okay. So anyway, let's see how can we use them. Okay. Or so every one of these instructions, guys, it should be written this way. You have to use one of these instruction, and then you have to put here a counter, comma, and you have to put a label. This label is where you want to loop. Okay. This counter, this is this is the counter of 4. Or as I told you, for 4, we need a counter. And it has to be a register. And this is a disadvantage. It cannot be a memory location. It has to be a register. Is that okay? So let's see what this instruction is doing. Okay. What this instruction is doing, guys, is the following. Here, I'm going to put a counter here, okay, which is a register. Number 1, this instruction is going to decrement the counter. This number 1. Number 2 is going to compare it to 0, okay? If it is not equal to 0, it's going to loop. So that's what I told you. That's why this one is very interesting, because this one is going to do 3 operations. 3 operations. Number 1 is going to decrement the counter. Number 2 is going to compare it to 0. Number 3 is going to, if not equal to 0, it's going to branch to next. Okay. So let's see how can we use it to create a full loop. Okay. So I'm going to explain here how can we use it. Look here, guys. Here, I decided to use register A as a counter. For example, I'm going to initialize it by 10. I'm going to initialize it by 10. Okay. Because I want to loop 10 times. So see what's going to happen here, guys. Look how it is very simple. Very simple. The loop here is very simple, right? Okay. So every time I come here, we are going to decrement A. We are going to decrement A. This instruction is going to decrement A. And then if A does not equal to 0, it's going to loop back. That's it. So what's going to happen here? In the very beginning, we're going to come here with 10. Next time, A is 9, A is 8, A is 1, A is whatever, until A is 0. This one is, if it is 0, it's going to come here. As long as it is not equal to 0, you are going to keep looping. Any questions? The distance from here to here has to be short, because you are going to jump from here to here. So this one should be short, cannot be long. So that means this one, it cannot be more than 128 or one, I don't remember, 128 or bytes. So the amount of instruction you should put here, it should not be more than 128 bytes instructions. Okay. In the memory, they should not take more than 128 bytes. Okay, guys. So let me explain it before, and then I'm going to give you more example. But the idea here, I'm going to use the register A as a counter. I'm going to initialize it with number 10. Then in every iteration, I'm going to come here. This instruction is going to do 3 operations. Number 1 is going to decrement A. Number 2 is going to compare it to 0. If it is not 0, go back. Not 0, go back. Not 0, and every iteration, I'm going to decrement A by 1 here in this instruction. Once it is 0, we're going to go outside here. Okay. Any question? Very simple, because it's just one instruction. Okay. Okay. I can do it in a different way. Again, I told you guys, this programming, you can do the same thing in different ways. So now, for some reason, I told you here we have decrement and branch if not equal. We have decrement and branch if equal. We have increment and branch if not equal. So increment and branch if equal. Test, branch if equal. Test, branch if not equal. Okay. So these are all the tools you have. Then use the tool that's suitable for you. Maybe in the whole course, maybe you don't need some of them. So for example, if you ask me about test, maybe you don't need it. Okay. Or maybe you are going to need, but again, this is a tool. It depends on the programming problem you are trying to solve, if you need it or not. So let's have another example. Here I used decrement. Now I'm going to use increment. Yeah. So look here what I did, guys. So for example, if for some reason, if I want to use increment and branch if not equal to 0, right? So here I'm going to start from -10. Here, -10. Okay. Every iteration, this one is going to increment by 1. And if it is not 0, go up. So that's why our counter should be -10, -9, -8, and so on. Every iteration, every time we come here, we increment 1. We increment A. Okay. And as long as A is not 0, it's going to go back. Once A is 0, it's going to go outside here. Okay, guys, any questions? I'm going to tell you some programming trick. Okay, I told you the jump from here to here. The jump from here to here, it has to be short. I'm going to tell you a programming trick to make it long. Okay, I'm going to tell you how. So maybe something interesting to learn. Look here, guys, the way I'm going to do it. Here, I want to start from 10. So this example is actually similar to this one. Okay, So I'm gonna start from 10. Every iteration, I'm gonna decrement A. Okay, so let's see. Okay, I wanna show here the version, the short version, in order to understand how I made the trick. Okay, so here I wanna loop 10 times. Okay, so I'm gonna start from 10 as you see here, guys. Then I'm gonna say branch, decrement, and branch if not equal. Okay, A comma begin. Sorry, yeah, begin. So this is, as you see here, guys. Here I'm gonna make for loop for 10 iteration, as you see here. So every time I'm gonna start from number 10. Every time we are gonna decrement, and if it is not 0, go back. So we're gonna make 10 iterations here. Is that okay? Okay. However, this jump from here to here, it has to be short. Is that okay? I'm gonna show you how I'm gonna make a programming trick to make it long. Look here. Instead of using decrement branch if not equal, look here, I'm gonna use if it is equal to 0. So let's see how it works. So every time I come here, I'm gonna decrement A. Once A is equal to 0, come here. If not, if A does not equal 0, if not, so I'm gonna come to this long branch. This one is gonna branch me to the beginning again, long branch. So here, this is a short branch because this one, the idea here, I'm not gonna use this one to branch all this distance from here to here. No, once it is equal to 0, so I'm gonna use this one to make a short branch to here, go outside here. Anyway, it's just a trick, small trick. So here again, the way I did it here, guys, I'm gonna look for not equal. If it is not equal, go back. This is the way I made it here. The way I'm gonna make it here, once it is equal to 0, go out. If not equal to 0, this branch is not gonna be taken. If not equal to 0, and then I'm gonna put this one here to make a long branch to here. Okay. Anyway, that's just. Again, guys, look here what I want to say, guys. I'm teaching different ways. So and then when you program, you can use whatever you want to use. So for loop, I taught in full loop, how can we use compare and branch instruction to create full loops? I taught this one. I taught that you can use memory location or register to make full loop. Okay. Also, I explained how can you use loop instruction, someone like this one, and it is short. Also, I'm teaching how can you make like a small trick to make it long. So I'm explaining different ways. Okay. Again, this is how programming should be taught, in my opinion, different ways. And then whatever you like, as long as I told you before, in any exam, in test, in quizzes, whatever, I'm not gonna force you to unless I ask you for something. But usually, to me, as long as the program is working, it's good. Okay, so I'm not gonna force you to use a certain way. Yes. This one is short. We don't have a long version for this one. The trick I made, I'm not gonna use this one to jump all the way to here because maybe you have too many instructions here. Maybe you have too many, but no, it has nothing to do with the number of iteration. It's related to how many instructions you have here. Just true. How far begin from this instruction, right? In memory, how far in memory? So if you put here in memory, so the distance from here to here in memory, it should not be more than 128 bytes. Okay. So if you on average, if every instruction is going to take 3 bytes, for example, so how many instruction you can put here? It's going to be 128 divided by 3, whatever it is. So for example, it's at 40. So you can hear, you should not put, yeah, roughly 40. You should not put here more than 40 instruction. Otherwise, you are going to get error. Okay. And the error, the good thing, error like this one, the code error is not a logical error. This is a good thing, right? So code error is going to give you a message, error message. Code error is going to tell you something like out of range. So if it tells you this branch is out of range, so you should understand this. This is you are trying to make a long branch and you are using short instruction. You have any other questions? Yeah. Okay, guys. Then, so now I want to answer a question about, okay, so we have too many other things. How can we use them? So we have, we have like tests. Again, these are tools. You can use whatever you want. For some reason, if you want to use this one is not going to increment or decrement the counter. This one just a test. It's going to compare the counter to 0. So this one is not gonna decrement or increment. Okay. For some reason, if you want to use it to make a full loop, in this case, you have to use instruction to decrement A, as you see here. Okay. So every iteration, I'm going to decrement A, and then this one is going to test. It's going to test if A, as long as A does not equal to 0, it's going to keep looping. Okay. You can use it this way if you want to make full loop, or maybe here there is a condition. Once the condition happens, so I should not keep looping. Okay. And in this case, I'm going to put 0 in A. So here you have to write some instruction here. Okay, if you want to leave, so I'm going to put a 0 in A. Otherwise, I'm going to put something else other than 0 here in A if I want to keep looping. You got what I'm saying? So here, what I'm explaining right now, it's not like for loop. It's more like while loop. Okay, for example, you have a condition. Okay, the condition didn't happen yet. So in this case, I'm going to put in register A value greater than 0. Okay, to keep looping. Once I want to leave, so I'm going to, before I come here, but this one is not going to increment or decrement. This one just test. It's going to test, right? Anyway, any questions? Okay. I want to also tell you something very important. It's a common mistake. You should not do it. And I already explained something similar to this one in the last lab, related also to the last lab. Look here, guys. I wanna make full loop. Okay, that's easy. You wanna make full loop, so I'm gonna use register A as a counter. I'm gonna initialize register A with 10, as you see here, and then every time I'm gonna decrement, I'm gonna branch if not equal to next. So by this way, using this instruction, I'm gonna create full loop. You are gonna full loop several times here. Is that okay? Okay. So listen to me. So I'm gonna use register A as a counter. That means in the very beginning, A should equal to 10, 9, 8, 7 until it is, once it is 1 and you decrement to 1, it becomes 0. I'm going to leave. Is that okay? However, maybe because we don't have too many registers, so already register A, it should hold, register A is storing a count. And this count is important for sure, because every iteration, I'm going to decrement this count. Once it's 0, I'm going to leave. Is that okay? Now let me ask you a question. Here in the body of 4, what if I want to use register A for something? I want to do multiplication. You know, register A is almost used in all operations. If I want to do multiplication, division, whatever, and I want to use register A, okay? For sure, you should not lose the count. So as I told you in the last lab, something similar to this one. Okay, so register A is storing a count. So all what you have to do, you have to store the value of the count somewhere. Then you can use register A, and then you have to get it back before you come to here. Make sense? In order to make counting. Make sense? I remember in one lab, in one lab, a student had infinite loop. When I went there, he was expecting to have like 10 iterations or something like that. When I checked the code, I found that what happened to the student is, here I'm going to start from 10. And this one, every time this one should do decremented. So this is the pattern that I should have. A is 10, 10, 9, 8, 7 until it is 1. But what happened is that I started by 10, and then the student here used register A to do multiplication and division. So A became random number. So when I do multiplication, A is 20. Then I'm going to come here, decrement 20. Is that 0? No. When I go back, I'm going to do another multiplication. A is 10, A is 5, A is 5. So it's not going to have this pattern. A became random. That's why he had like infinite loop. You got him? So anyway, because A is storing a count, and I need to keep this pattern for the count. All what you have to do, guys, you have to store that. If you want to use register A, you have to store this value somewhere and then use register A and then get it from somewhere. What do you mean by somewhere? For now, I mean somewhere and memory location. So you can make a temporary memory location, you can store it and then get back from this memory location. More later, I'm going to explain, and this is a professional way to do it, is by using stack, as I'm going to explain later. So later, I'm going to say, I'm going to tell you push A. Push A means I'm going to store the value of in the stack. Then I'm going to say, once I need it back, I'm going to say get it back from the stack. Okay, so I'm going to explain this one later in the stack, and it's actually more professional and much better way than just use memory location. You know why? As I'm going to explain when I come to the stack, because what if I want to push too many values? What if I want to push too many values, right? So should I like how many memory location I should reserve? You get what I'm saying? So in case of a stack, you can just push in the stack. So you got what I'm saying? Maybe in one iteration I need to push 10 elements. In other iteration, maybe I want to push 20 or whatever. Okay. Another problem, I need to reserve memory. I need to define memory location. I need to remember this one went to do this memory location, so I have to get it from this memory location. Anyways, it's not convenient for programming. A stack, I'm not gonna tell the stack what memory location. I'm gonna just stack, save this one, stack, give it back to me. So it's gonna be much easier, more professional way. Okay, guys. I told you in the last lab, or in lab 5. In lab 5, we had this problem, but it was for one of the pointers, because in the last lab, we should have used X and Y. We have to use both of them in lab 5. Why? Because we have two arrays. Let me see if I have space. Yeah. So we have data array. This is the array that has a delimiter this way. This one I'm going to use, for example, register X as a pointer for this one. Register X has to go this way. Also, there is another array. I call it multiply 10, I guess. I don't remember the exact name. So here, this one, I have to use also pointer here Y. As I told you, in one iteration, I have to take this value. I have to multiply it by 10, and then I have to store it here. Okay, so that means that, and both of them should be moving. So for example, this is array of bytes. This is array of words. So it should work this way, guys. Look here. This is element number 0, element number 1, element number 2, and so on. The other one here, because it's array of words, so this is element 0, and these two should be element 1, and these two should be element 2, and so on. So what happens when X is here, Y has to be here. This is in the first iteration. Then you have to increment X by 1. You have to increment Y by 2. So this one is pointing at element 1. This one also is pointing at element 1. So both of them are moving. Okay. In next iteration, I'm going to increment X by 1, but I have to increment Y by 2 because this array of words, both of them are moving. Every time I'm going to get the element pointed by X, I'm going to multiply it by 10. Then I'm going to store the result in the element pointed by Y. Is that okay? So inside the while loop, you already created a while loop. Inside the while loop, it's gonna so X is storing an address, Y is storing an address. Is that okay? It will happen that in order to do multiplication, I want to use register Y or X or whatever. Okay, guys. So in this case, as I told you, very simple. Okay. Now X is storing an important value as a pointer. Okay, so in this case I want to use X or Y in multiplication or division or whatever. Very easy. Just store X in a certain memory location. You should define it, and then after you're done, get it back from the memory location. Is that okay? Any questions? Okay, guys. Also, I explained this one last time, guys. I told you if your counter is a byte, you cannot make more than 256 iteration because I'm gonna count from 0 until 255. This is a maximum number. Got what I'm saying? By the way, let me ask you a question. When you count from 0 to 255, after 255, if I increment 255, what I should get? 0 again. Yes, that's exactly how it works. So if you start from 0, 0, 0, 0, 0, 0, and then you increment, it becomes 1 all the way until 1, 1, 1, 1, 1, 1, 1, 1. This is 255. If you increment to 255, you are going to get 0, 0 again. Okay. So the maximum I can make, I'm going to start from here. I'm going to end here. Is that okay? Same thing if you use, so what if you need more? What if you need more? If you need more, you can simply, instead of using a word, instead of using a byte counter, you have to use a word counter. Is that okay? And in case of a word counter, you can make up to 65,536. This is from 16 0 until 16 ones. Okay. Yes. Check the instruction set. I don't remember. I don't remember it. So you can check the instruction set. Yes. Okay. So I want to tell you something here important. I know many students are making this mistake. Please, you can save your time if you listen to me. Okay. For example, in this example, guys, here I'm using a counter as a byte. So if you want to use it, if I want to use it as a word, so here I have to use W instead of B, as you know. Here I have to use move W instead of move B, as you know. More importantly, and this is a common mistake, you cannot decrement this way, as I explained before. As explained before, this decrement is for a byte, not for a word. Unfortunately, this is a logical error. Code word is not going to give you error here. Okay, it's a logical because it's going to work, but this one is going to only decrement. You know, counter should hold to 2 locations because it's a word. So this instruction is going to only decrement the first byte, not the second one. So it's not gonna take the 2 bytes as one word. No, it's gonna only decrement the first one. So you have to be careful here. This decrement or increment is gonna be for a byte. So if you want to decrement, the only way or one way to do it. So for example, you can say load register D with counter. For example, you are gonna use counter in D, and then you can subtract D. 1, you can subtract number 1 from D, and then you can store D back to count. This is the way you can do it. Okay, so because it's a word. Okay, same thing for increment. Any questions? Okay. Now, what if you need more? What if you need more iterations than 65,536? Okay. Is an easy way to do it by nested loop. Nested loop. Nested loop means loop inside the loop. Loop inside the loop. Okay. So for example, in this example, if I make this loop, if I loop here 1,000 times, and then I have outer, I have here outer loop, and here I have inner loop. The inner loop is going to be 1,000, and the outer loop is going to be 100. By this way, you can make 100,000. So this instruction are going to be repeated 100,000. Any questions? Okay. Same thing here. I want to show you how can you use these branch instructions. The loop instruction. How can you use them with a word counter? Okay, so this is just similar to what I explained before. For example, here, look here, guys. I wanna make 6,000 loops. 6,000. Okay, so I'm gonna use register X as a counter, as you see here, guys. Then I'm gonna do it this way. I'm gonna say decrement and branch if not equal, and then I put here register X. So every time I come here, this instruction is gonna decrement X. If it is not 0, go back. Not 0, go back. Not 0, go back until it is 0. Okay. You can do it in a different way. So let's, for example, I'm gonna do this way and see how they are different. Okay. For example, I can say here, I'm gonna load. Here, look here, guys. Here you do the iteration first and then you decrement. So you do one iteration and then you decrement and then you check. Okay. Here I'm gonna check in the beginning. Let's see how this make a difference. Okay. So here I'm gonna decrement X in the beginning. Once it's 0, go outside. If not, I'm gonna come here. Then I'm gonna I can here make a branch loop if you want. So I can make it a branch but so sorry. So here, what I'm gonna do here, I'm gonna decrement in the very beginning. So here I'm gonna decrement x. Okay, if once it is 0, go outside. If it is not, I'm gonna come here and then come back to the beginning again. Is that okay? So the question is that, again, sometimes even myself I get confused. Okay, so for example, if I put here 6,000, so I'm gonna get 6,000 or maybe one more or one less, or same thing here. Because here you check, here you decrement first. Here you do one iteration and then you decrement. I think the best way to remove any confusion, just to try it with a small number. For sure, you should not try 6,000 for sure. It's gonna take forever. So for example, here I'm gonna try with number 2, and then I'm gonna see if I put in number 2, I'm gonna make 2 iteration or 1 iteration or 3, right? So because sometimes there is one more or one less or something like that. Let's see. So here when I did 2, guys, this was gonna happen. Number 1, we're gonna come with 2. Then this one is gonna decrement. Okay. So now is 1 is equal to 0? No, it's not equal to 0. So I'm gonna go back to make another iteration, another one. In the next one, okay, but this time it is 1 because I decremented here. 1, then I'm gonna decrement 1, becomes 0, so I'm gonna leave. So if I put in number 2, so by this way I'm gonna make 2 iterations. Okay, guys, because you do the iteration first and then you decrement. Here in this one, by the way, here you decrement it first and then you do you do 1 iteration. Okay, so let's see if here, if I put here, for example, number 2, if I put number 2 here, so actually you are going to do only one operation. So for example, here, if I put here number 2, guys, okay, I'm going to come here, decrement. So now x is equal to 1, right? Then I'm going to come, when I go back to here, decrement, it is 0, just leave. So if I put 2, I'm going to get only 1 iteration. That means if you want to make 6,000 iteration, you have to add 1 here. Okay. Again, guys, I don't listen to me. This is very important. Okay. Again, I am teaching different ways, different approaches. Okay. Because this is the way programming should be taught, different ways. Okay. So whatever there is, as long as all of them are doing 4, anyone you pick or anyone you select should be okay. You understand what I'm saying? Any question, guys? Okay. I think I explained all of that here. I think this is the end of this section. Again, guys, very important. Please listen to me. This section is very important. All the time we're gonna do loops. All the time we're gonna do if statement. So this section is very important. That is why, as I told you in today's email, I'm not gonna post a new lab for this week. Okay, I want you to keep working on in lab 5 to understand it better. This lab is very important. This section is important as well. Okay. Also, I'm gonna give you a second quiz on this section as well. So already you had 1 quiz last time. I'm gonna give you another quiz. Okay. And again, if you need help, just at any time let us know during the lab or even outside the lab time, anytime. Okay. I want you to understand this section. It's very important. We're gonna need it all the time. Is that okay? Now, so let me tell you where are we here in this course so far. Okay. As I told you before, guys, this chapter 2 is a long chapter, maybe the longest chapter. 2 and 3 are long chapters. So in chapter 2, I teach assembly language. Okay. And then I'm gonna use this assembly language in the rest of this course after I finish. Okay. So I already explained data transfer instruction, load, store, transfer, exchange, and so on. Move instruction. I taught arithmetic instructions, decrement, increment, clear, and also addition, subtraction, add with carry, and so on. Okay, multiplication, division. Also here I finish this section, branch and loop instruction. Now I'm gonna move to next section here about shift and to rotate instruction and Boolean logic. The comment section should be very easy, very straightforward, very easy. Okay. So now we have some instruction to do shift and do also rotate. Also have an instruction to do the Boolean logic. The logic like AND, OR, XOR. Okay, I'm gonna teach this instruction. So I'm gonna start with shift and rotate first. Okay. Yeah, this topic should be very easy, very straightforward. Okay. Okay, so let me teach what do you mean by shift instructions. Shift, okay, you can tell from the English name shift. Shift is doing shift. Yeah, for sure. Shift is doing shift. You are shifting. Yes, I'm shifting the bits. So for example, if this is a byte and you shift the byte, what it means? It means this bit is going to come here. This bit is going to come here. So all the bits are shifted one position. That's what I mean by shift. And we have two types of shift. If you shift this way to your left hand, this is called left shift. If you shift this way towards your right hand, this is called right shift. So number one, so shift means every bit is going to be shifted by one bit. That means bit 0 is going to come to bit 1. Bit 1 is going to go to 0. Everyone is shifted. At the end, you have to lose 1 for sure. You have to input 1 and you have to lose 1. That's true. Okay. Also, we have right and left. That's what I'm explaining. Look here, guys. So for shift, I'm going to teach what we call logic shift and arithmetic shift. Every one of them, we have left and right. Okay. So let's start with logic shift. What it means, logic shift. Okay, and we have right and left, as I told you. So this is a byte here, guys. This is bit 0, bit 1, bit 2, bit 3 until bit 7. This is a byte. Is that okay? When I shift this bit to the right, as you see here, is a direction. You shift towards your right hand. Okay. So here, when I shift, actually, what's going to happen? Always we shift by 0. Always. So I'm going to put 0 here. And then bit 7 is going to go to the location of bit 6, as you see here. So this is after you shift. So after you do shift, after you do one shift operation, 0 is going to come here. Bit 7 is going to go to the location of bit 6. And so on. Bit number 2 is going to become in the position of bit 1. This one is going to go to the carry, as you see. This is one shift operation to the right. Makes sense? So if you have a byte and I tell you I want to do one shift operation to the right, that's exactly what is going to happen. You are going to 0, you are going to always, you are going to shift by 0. So 0 is going to come here to bit 7. The bit 7 is going to go to the bit, is going to go to bit 6 and so on. Bit 1 is going to come here. Bit 0 is going to go to the carry. Is that okay? If I shift again, if I shift one more time, if you shift again, okay. Again, you are going to put 0 and 0 and then put 7, bit 7, sorry, and then until bit number 2. And the carry should have bit 1. Is that okay? If you shift again. What about the old value here? What about B0? You overwrite it. It's gone. You overwrite. So the carry is storing a value. When you overwrite it, the old value is gone. You overwrite. You get what I'm saying? Any questions? Don't ask me. Don't ask me how we're going to use it, because this is something I'm going to explain how this can be useful. I'm going to explain it. But let's now focus on what do you mean by shift, what instruction we are going to get we have here, and so yes. Yeah, that's what I'm going to teach you when I talk about arithmetic shift. You can tell from the English name arithmetic. Arithmetic, that means you are doing something math here. As you mentioned, we can use the shift to do multiplication by 2, quick multiplication by 2 or division by 2. Very quick, much quicker than using multiplication or division instruction. Anyway, so same thing. This is for shift to the right. I can shift on the other direction. Okay, this is called shift to the left, this way. Okay, it's exactly same thing, but look at the direction. In the other direction, we call it shift left. So in logic shift left, we're going to shift by 0, guys. Every bit is going to be shifted by 1 position. The bit number 7 is going to go to the carry. So this is what you are going to get here. Make sense? Any questions? Just I want to understand what I mean by shift. Okay, so what shift means? Always we are going to shift. Shift means every bit is going to be shifted one location, right or left. This number 2. Always you shift by 0. Number 3, the last bit is going to go to the carry. Always. And all the students are confused. What about the old value of the carry? You overwrite it. You overwrite it, so it's gone, right? So this is what we call logic shift. Now we have another type of shift. We call it arithmetic shift. Arithmetic shift. And why it's called arithmetic? Because as I'm going to tell you right now, shift can be used for multiplication. If you shift left, actually you multiply by 2. If you shift right, actually you divide by 2. Let's give me example. I don't know how this can be multiplied by 2 and divide by 2. How? I'm going to tell you. Look in this example, guys. What this number is? This is number 4. When I shift 1 to the left, now it became 8. When you shift again, now it became 16, and so on. So every time you shift, you are gonna multiply by 2. You double the number. You got what I'm saying? Okay. So that is why sometimes people are using shift to do quick multiplication by 2. So every one shift operation you multiply by 2. Every one shift operation you multiply by 2. Shift left, you divide by 2. So if you look at this example, guys, here, this is 16. If I shift it to the right, okay, it becomes 8. If you shift it to the right, it becomes 4, and so on. Okay. So that is why one of the ways we can use shift is arithmetic, multiply by 2 and divide by 2. Okay. Now, I told you guys, now we have 2 different types of shifts. We have logic shift. I already explained how can we do it. Logic shift this way. Now, I want to explain, do we have another instructions I'm going to teach for arithmetic shift? Is that okay? How they are different? I'm going to tell you how it is different. Let's first, for here, so here for arithmetic shift left, guys. The arithmetic shift left, it works this way. All the time you shift by 0, and the last one is going to go to the carry. But this is the same thing like the logic shift left. Yes, it's the same. So in case of shift left, right? Both the arithmetic and the logic are the same. They are doing the same thing. When you are going to shift by 0, the last one is going to go to the carry. Both of them are the same. Okay. However, in case of shift right, they are not the same. They are different and right. Why? Because if I go back here, in case of logic shift right, you shift by 0, last one has to go to the carry. But in arithmetic, I'm not going to shift by 0. I'm going to shift, look here, I'm going to shift by the sign bit. Here, I'm going to shift by the sign bit. If the sign bit is 0, I'm going to shift by 0. If the sign bit is 1, I'm going to shift by 1. Okay. Why? Why are you going to shift by that? In order to divide by 2. In order to divide by 2. I'm going to give you example here. Look here, guys. For example, this number is positive 2, right? So if I shift by 0, it becomes positive 1, right? But this number here is negative 2, right? If I shift by the sign bit, which is 1, if I shift by 1, so it becomes negative 1. Is that okay, guys? So conclusion, I'm going to tell you, yeah, you still have question? Okay. So let me tell you the final conclusion. The final conclusion, guys, what I'm going to teach now, I'm going to teach 4 types of instruction. I'm going to teach logic shift instruction for right and for left. Also, I'm going to teach arithmetic shift instruction also for left and for right. How they work? How they work? They should work this way. In case of logic shift, guys, in case of right, you shift by 0, and then the last bit is going to go to the carry as we see here. Okay. In case of right, in case of left, it's going to be the same thing. You are going to insert 0 from here. The last one here is going to go to the carry. This one is the same for logic or arithmetic. So left is the same. Left is the same in case of logic or arithmetic. However, right is not the same. Right, in case of logic, you are going to shift by 0. But in case of arithmetic, you are going to shift by the bit number 7, the sign bit. Okay, guys? Also, I explain why I didn't explain yet why I need to shift the bits. I have a byte. Why you need to shift it? Other than I explain one thing now, which is arithmetic, multiplication by 2 and division by 2. But what in this course we are going to use also for something else. It also can be used for other things, as I'm going to explain. I give you some examples as well. Okay. So now I'm going to teach what instruction we have to do this shift. Okay. For the logic shift, we have only 4 instructions, as you see here, guys. Letter L for logic, S for shift, L for left. So we have LSL, and then here you have to put here address for memory location. And this, so here, so this one is like when you say like increment, and then you have to put here a memory location. It's the same thing, but it has to be LSL. So this one is gonna shift a memory location, but this memory location has to be a byte. A memory location, this memory location has to be a byte. Also, you can shift the left register A, you can shift the left register B as well. Also, we have only one instruction, logic shift left for register G. This is the only one we have for a word. So very easy. So for the logic shift left, we have 4 instructions as you see here. We have 3 instructions for bytes and 1 for word for register G. In case of register D, as you see here, guys, okay, when you shift here, when you shift left this way, as you see here, what's gonna happen here? Sorry, this is shift left. Yeah. The direction is not correct. This one is shift left, so it has to be this way. I'm sorry. I think there's something here. You have to put 0 here. You have to shift by 0, and then the last one it has to go to the carry. Okay. In case of right, you shift by 0, and the last one go to the carry. So to make it left, okay. So here you shift by 0, and the last one has to go to the carry, and then yeah, whatever here is going to come here because it's just one word. Okay. For right, shift right. Okay. In case of shift right, we have exactly same instruction. So we have here these 4 instructions. We have exactly same instruction here, guys. But just I'm going to replace letter L here by letter R. So here we have logic shift right for register A, logic shift right for register B, logic shift right for register D. Is that okay? Very easy. Okay. For arithmetic instruction, same thing. For arithmetic instruction, we have here the same instruction here. We have the same ones here, but instead of using letter L for logic, I'm going to use letter A for arithmetic. Right? That's what we have here. Look here, guys. Arithmetic shift left, and then here you have to put a memory location. Again, this memory location similar to what I explained to before. It can be any format for the different formats of memory. So it can be something like 1000, it can be 0, x, it can be a, x, it can be 1, x plus, it can be any one of these formats. Also, this is for a byte, not a word. Okay. Then you can arithmetic shift left for A, arithmetic shift left for B, and then we have arithmetic shift left for register G. This is a word. For right, we have everything here similar to this one, except for some reason they didn't make this one. So we don't have this one here. Okay. So so here, as you see here, we have arithmetic shift right for, and then memory location, arithmetic shift right for A, arithmetic shift right for B. Now I want to have examples. So I finished explaining the shift instruction we have. Okay. So let me, I put all these instruction in one table just to make it easy for you to find them. Okay. Yeah. as you see here, guys. Here I put here logic shifts, all the logic shifts we have. Here I put the arithmetic shifts. So all the arithmetic shifts we have. Is that okay? And then I'm going to explain the rotate later, rotate instructions. So already summarized here in this table. Okay. So now I'm going to just want to give you examples. So now, guys, what I'm expecting from you guys now, number one, you should understand what shift means. When I tell you shift right, what it means, shift left, what it means. Okay. Number two, what instruction we have to do shift, what instructions. Okay, that's what I see. What I'm going to do right now, I'm going to give you example. How can I use this shift? Okay, guys. So for example, here, every instruction I taught here, guys, this instruction is going to do only one shift operation. So when I say here, logic shift left for A, so this one is going to shift register A to the left, okay, only one time. So what if you want to shift 2 times? So you have to repeat this instruction 2 times. For example, yes, that's what I'm explaining here. So if I want to shift register A 3 times, so I have to write it 3 times. Is that okay? Because every instruction is going to shift only 1 time. And for sure, after you shift 3 times, this is how this is register A. Okay. So what's going to happen after you shift 3 times? So I'm going to get F here 0 0. Is that okay? And then here, these are 3 bits. And this part is going to come to here, move to here. Make sense? Let me give you a numerical example, but that's how it should work. If this is register A, every time you shift, you are going to insert 1 0. And 1 bit is gonna go away. Another shift. So after 3 shifts, you should see here 3 zeros, and then this part should come to here. Make sense? Okay. Also, what happens? What happens if I shift 8 times for register A? What do you think was gonna happen after you shift 8 times? Yes, because every time you shift, you insert 0 0 0 0 0. So after 8 times. So this one is going to be similar to clear A, right? Now the question is, okay, you told us I'm going to use shift for multiplication and division. If you want to use it like arithmetic, are you going to use it for something else? The answer is yes, we will. Okay, we are going to use it. You do it for like bit manipulation. Bit manipulation. Again, you are going to. So let me explain exactly what we're going to do here. In one, we are going to need it in one of the labs. One of the labs in chapter 3. Can you see these 8 switches? 8 switches. As I told you before, these 8 switches, okay, they are connected to 1 byte. 1 byte, as I explained before, okay. They are connected to port H. So these switches are connected, guys, to port H. And port H is a byte. So what's going to happen? You cannot only read 1 switch or 1 bit. You can't. I have to read the whole byte. And then after you read the whole byte, you can do manipulation on the byte. Okay? But you can't read only 1 bit. So I have to read the whole byte. That's true. So now I'm gonna read the whole byte. Okay. And then you can do some so here in this byte, every bit is going to tell you if the corresponding switch is connected or not, as I told you, and as I'm going to explain details in chapter 3. So if this one is 0, that means the switch is connected. If the corresponding switch, so every switch here is going to have 1 bit in a byte, right? Every time you connect the switch, the hardware is going to put 0 in this byte. So when I read the byte, I'm going to find 0. Every time you disconnect the switch, the hardware is going to put 1. When you read the byte, you find 1. Right? That's why one of the very important things I'm going to explain also is, and I already explained, but I'm going to explain it later in a different way. If you have a byte, how can you check 1 bit? Just I already taught this one last time. You remember I explained how can you use branch if clear, branch if set. So this is something very important. We're going to do it all the time. You have a byte, and then I want to check some bit to know if the corresponding switch is connected or not. You got what I'm saying? So I already explained branch if clear, branch if set. Okay. However, the branch if clear, branch if set, they are short. They can't be long, right? That's why there is another approach I'm going to explain. In this approach, I'm going to use logic AND, but forget it for now. I'm going to explain later. So I'm going to use logic AND to check some bits. I'm going to, okay, so it's going to do the same thing like branch if clear, branch if set, but this one is going to be long. I'm going to use logic AND. Okay, I'm going to explain it later. Forget it for now. Okay. Okay, so here, let me be more specific here. So in one of the labs, I'm going to tell you, get a number from the user. This number should be from between 0 and 15. So I want the user, I want the user to give me a number from 0 to 15. And then I'm going to use this number to do something. Okay, so I'm going to get a number, and then I'm going to use this number to do something. To be more specific, in this lab, this number you are going to get from the user is going to be the delay of the flashing. So I want to use one of the LEDs here to do flashing. You know, flashing, turn on, turn off, turn on, turn off. So you can control the speed. So if the user enter 1, okay, so I'm going to do flashing 1 second, 1 second, 1 second, 1 second. If the user enter 2, so I'm going to do 2 seconds, 2 seconds, 2 seconds, 2 seconds, okay, and so on. Because I'm saying. So the question is, or the way I asked you to do in this lab is, I have here 8 switches. So I told you the user is going to use these 4 switches. The user is going to use these 4 switches to enter a binary number from 0 to 15. So if the user enter 0, 0, 0, that means it's number 0 here for these 4 switches. If the user enter 1, 1, 1, 1, so that means it's 15. So here what I'm saying is that I'm going to select the last 4 switches. 1, 2. So I'm going to use the last 4 switches, okay, to enable the user to give me a binary number from 0 to 15, right? And then I'm going to use this number to do something, okay? So the problem now is what I'm going to get when I read port H, I'm going to get a byte, a complete byte. My number is here. That's what I'm interested in. So here, my number is here. But what about this one? I don't care about this one. So here, I don't care about this part. You get what I'm saying? So what you have to do in this lab is, after you read the byte, you have to shift it to the right 4 times. After I shift it to the right 4 times, what I'm gonna get is, I'm gonna get these 4 are gonna become here, and then 0, 0, 0, 0, 4 zeros. Now I have a byte, and this byte should be a number from 0 to 15 given from the user. You got what I'm saying? So let me say it again. This is the number I want to cut. I want to cut this part because my number is here. The user is going to use these numbers. The user is going to use this number, these 4 switches to enter a number from 0 to 15. So now I want to convert it to a byte so that I can use it. Once it is a byte, you can multiply a byte, you can divide a byte, you can use it. You got what I'm saying? You can, if you byte, you can sign extend it to a word. You can do whatever. So here, what I'm going to do, I'm going to shift 4 times. When I shift 4 times, now I have a byte. This byte is storing a value from 0 to 15 given me from the user. This is just one example. How can we use shift? You got what I'm saying? Any question? There are other examples also I'm going to teach, but this is just one example. How can we may need to use shift? Wow, it's already 5:15. Okay, guys, so I'm going to complete next time. Okay, thanks so much.